All right, we're live. Yesterday, we looked at the parent function y equals x cubed, and we discovered that it looks like that. And we discovered that we could come up with an equation with all the different transformations that looked like this, where A was our stretch compress, that H was our left-right shift or horizontal shift, and that K was our up-down shift or vertical shift or kangaroo shift, if you need a way to help you remember it. And this sort of went along with what we talked about before, which was we've investigated y equals x squared quite significantly. We'll spend a lot of time on that one. Graph looks like this, and we had y equals x minus h squared. Whoops, I put a squared on the cubed, so you want to change that to a cube, plus k. Just notice that the pattern is the same. We replace x with x minus h, we put a plus k on the end, and we multiplied by a stretch factor out front. And today we're going to look at a couple more functions, and we are going to start with y equals the square root of x. So what I want from you first is I want a full investigation. And remembering what we talked about yesterday, we're going to have a table. We're going to have a graph. We're going to have x and y intercepts. We're going to have the domain and range. We're going to figure out if there are any asymptotes to this function. We are going to write a description. Full investigation. Y equals square root of x. You can use Desmos, you can use a graphing calculator. When you're doing the table, don't forget, be thinking about quick graph. What are good points for your quick graph? In other words, avoid decimals whenever possible. Morning, Alex. I don't know if you had heard that, Alex, but full investigation, y equals square root of x. So all the stuff written on the board here, I don't think I forgot anything. Table graph, intercepts, min range, asymptotes, description. Did I forget anything?
Important points.
Thank you. Important points. And of course, that's, important points other than the intercepts that we've already got on our list. So if there's anything that's like, oh yeah, that seems sort of important. Cool. So 6 or 7 minutes at the most. Should be getting good at this.
Mr. Armadine.
Good morning. We are investigating y equals square root of x. Third one down under the word parent there, so. See what you can come up with. Is it, oh, you got an extra, okay, because I was gonna say there's some on my table too.
Okay.
So remember the definition of asymptote. A line that a function approaches but never reaches. So this function stops, but it doesn't get closer and closer. Question. Is that a useful quick graph point?
No.
What would be, if you think about the next couple points, what would be a really good quick graph point? Boom, because then we got these beautiful whole numbers. Excellent. So, but there's the list of things on the board for an investigation. You got yourself a graph there. When you're doing your table, remember our quick graph where we're looking for really easy points to graph?
Do you have a graph data?
There's a pile on that little tray on the back thing. Question for you. In 2 1.41 and 3 1.73. Useful quick graph points?
No, they're not.
What's the next like awesome point that would be perfect for a quick graph?
4. So should I go up to 4 and keep on going?
Skip 2 and 3, put 4, 2 on there, and then do you need more?
No.
You got 3 points.
Yeah,
You see that curve?
I got.
Really all you need. Oh, go crazy on your graph, put all of them on there. Remember, we just want that one right now. We did those ones like last semester and yesterday. So, yeah, cool, good. Okay, another minute or so. Tell me about quick graph points. Which ones would you put on a quick graph out of that list of points you have on your table? Yeah, I wouldn't even put the other 3 on the table because we don't need them. You know, once we have enough to show our pattern, we don't need anything else. x and trying to graph the decimals accurately, well, you're gonna be approximating. You might as well just put the other ones on and draw the line or the curve. Cool, let's do it. Let's see what we got. Brett, give me one. Go.
So you want like -1 because that's undefined.
I don't know. Do you want -1? It's your table.
Okay. 0, 0, 1, 0,
Wait, what?
or 1, 1, 8. It's 1, 1.
Excellent.
And then I messed that up then. 2, 1.41.
Pause right there for just a second. Do I really want 1.41 on my quick graph table?
So should I just skip the 4
What do you think? It's your choice.
and just 4, 2, I guess.
Yeah. Guys, you could put anything you want on this table. You could put the decimals on this table. I mean, you're doing an investigation. They are part of the function. But the question is, are they useful? You want to put useful information down in an investigation. And 2, 1.41, well, I'm not going to be able to graph that one very accurately anyway, so why even bother trying? Why not do the whole number graphs? 1, 2, 3, 4, 1, 2, at 0, 0, 1, 1, and 4, 2. Hey, notice that's a curve. I got my graph. You only need 3 points, and you've got a beautiful square root function graph. Now, where is 2, 1.41? Well, apparently it's somewhere in there. And where's 3, 1.7 something? Apparently it's somewhere in there. But was my graph going to be more accurate if I tried to approximate those 2 points? No. So there we got it. Excellent. Cool. Thank you, Brett. Tyler, pick one.
X and Y intercept.
Tell me about them.
The x-intercept is 0, 0. The y-intercept is 0, 0.
Hey, Tyler, are there any important points on this graph?
Yes.
Where?
0, 0.
Remember I said important points, but that doesn't mean relist the x and y intercepts. But why is 0, 0 important other than being an x and y intercept, Tyler?
It's where it starts.
Exactly. We have an important point here that is a starting point. This function starts at 0, 0, and then goes flying off to the right. So even though it happens to be both the x and the y intercepts, it's a pretty important point to say, hey, look, this function starts right there and only goes in one direction. We don't have to even think about what happens. And Brett had referred to that when he said, shall we put -1 on the table? And then he decided not to. Yeah, we could have put -1 undefined if we wanted. We don't have to. But it goes right along with the fact that what is interesting about this graph is that it starts at 0, 0 and it goes to the right. It doesn't go to the left. One of the interesting things about this graph. Cool. Eddie, pick one. Go.
It's the domain is 0 to infinity.
What do I write?
It's bigger than x.
Is 0 bigger than x? Here's all my x's, and there's 0.
No.
What is 0 compared to x? It's not greater than x, it's
X
Okay, think about how we write inequalities. All of our x's, here's 0. Here, let me put some colors on here. Here's 0. Here's infinity, way up here. And all of our x values are in between, aren't they? Everything has to be in between 0 and infinity. Can't be over here. Has to be between 0 and infinity. Agreed?
Yeah.
So the way we say this is that our x values are in between there. So is 0 less than x, equal to x, or greater than x? Are these numbers bigger than 0 or less than 0?
Isn't X a changing variable?
It is. But what do we know about all these values of x? Are they bigger than 0 or are they less than 0?
Some of them are 0.
Okay, so could be equal to 0.
Oh, it's equal or greater.
0 is less than or equal to x.
Yeah.
That tells us that all the x's have to be either 0 or bigger than 0. Now, is x bigger than infinity or less than infinity?
X is not bigger.
Not bigger, exactly. You can't be bigger than, well, you could be maybe bigger than infinity, less than infinity. There's an interesting question. Is 2 times infinity bigger than infinity? No. How about infinity squared? Is that bigger than infinity? Whoa, now what? All right, Eddie, now that we've got that resolved, tell me about range.
0 is equal or greater.
Less
Yeah.
than.
Yeah.
Yeah.
Great. Equal or less than. Yeah. Infinity. Like X.
Well, range?
Oh, Y.
Good, good. Y, which is?
Less than infinity.
Nice. There we go. There we go. Hey, by the way, super good job not making that crucial error of putting an equals on the infinity part. Got to be just less than infinity. Can't be equal to. Very nice. All right. Good stuff. Thank you, Eddie. Hey, guys, I appreciate when you're not sure what he just did, which is working through it. That's awesome. Because we can usually come to an answer if we just work through it. Annie, go. Pick one.
Description.
Go.
Not a straight line.
Oh, well, first off, you don't have to say straight line, right? Because all lines are straight. So you could just say not a line because the straight is redundant. There's no such thing as a curved line. If anyone says curved line to you, don't even listen to anything they have to say about anything from then on. But I agree with you. But I don't like describing things in terms of what it's not. Because I agree with you that it's not a line. It's also not an elephant. It's not a SUV. It's not a pine tree. It's not a robin. It's not a cat. It's not a desk. See how we never get to anywhere because we just keep saying what it not is? But what is it? Think about the mathematical words that we used yesterday. Let me start you off with one. Is this increasing or decreasing? Totally increasing because I always read from left to right and this is going up. So this function is increasing. Now, which way does it curve and what words do we normally use? Do you remember those?
No.
Which way is the curve? Up or down? Really?
Oh.
Down. And what's the word we use to describe the kind of curve?
Concave.
Concave. Boom, there it is. concave down, increasing concave down. Guys, that's it. There's the description. This thing starts at 0, 0, and it increases, but it's got that curve downwards, that concave down. If I didn't even put this on the board and I didn't tell you what the function was, and I said, I've got a function starting at 0, 0, and it's concave down, you know it looks something like that. Oh my gosh, look, you got a square root curve. 3 words. I was going to say 2 words, and then I remembered it's 3. Increasing, concave, down. Boom, it has to look like that. Cool? All right. Isaac, pick one. Pick that one.
Yeah, that's the only, that's the only one I didn't do.
Okay, let's talk about it now. Is there a line that this function approaches but never reaches? But that's a point. Is there a line that this function approaches but never reaches? No. No, because Eddie told us it goes to the right forever and it goes up forever, which means that there's nothing it's never gonna max out. It's never gonna get closer and closer and closer to 100, but never get past 100. No, Eddie said it goes on forever. So they're definitely not an asymptote in this direction. And right here, just stops. That's not the definition of an asymptote. An asymptote is it keeps going forever and it keeps getting closer and closer and closer and closer. So yeah, the correct answer is none. There is no asymptote on this function. But that's an awesome investigation. Cool. I want to take that graph and I want to move it up by 4. What are you going to do to the equation to make that move up by 4?
Plus 4.
Don't shout it out. Just because you're smart.
Oh, sorry, I was just answering the question.
It's okay.
What you were asking.
If you think you know, make sure you test it in your calculator or Desmos on your Chromebook. So make sure you're testing it. And of course, you guys might even know where this is going. What am I going to ask you next? Down. And then what am I going to ask you after that? Okay. So I'm going to ask you to shift it down, and then I'm going to ask you to shift it up or down by some value k. So you can be thinking about this. If you already got the up. I'll give you a minute to think, process. Avery, how do I change the equation, make it go up by 4?
Plus 4. Y equals square root of x.
Notice that plus 4 is not inside my square root, agreed? Hey, have I ever told you about that little tail on my square roots? This is what I learned way back when in high school. If I write that, do we agree that that's the square root of x? Is that the square root of x? Is that the square root of x plus 2, or is it the square root of x plus 2?
That's plus 2.
You sure?
Yeah.
How do you know?
Well, I mean, you probably don't mean it to, but because the line goes all the way over to plus 2.
Does it? Looks to me like it just goes over the plus and then a little bit over the 2. Was I being sloppy, or did I mean square root the whole thing?
Being sloppy.
So, notice the difference. That is clearly the square root of all of that. This is clearly the square root of that plus this. This is, I don't know what Mr. Armberding meant to write there. The way I keep that from happening, the way I was taught, is I put a little tail at the end of my square root. And it's not really for anybody else's benefit. You don't need to see the tail. But what the tail does for me is it forces me to think, oh, where am I ending this when I'm drawing it? If I stop right here, well, clearly I'm not going to put a tail right there because that wouldn't make any sense at all. And it forces me to think, where do I want my square root symbol to stop? I want it to stop after the x. I want it to stop after the 2. And so it's a really good way to not get sloppy when you're doing your own math writing, because you have to very carefully think to yourself, where do I want that tail to be? Oh, I want it to be right there. And you stop your square root symbol. So that's how I was taught. And that's why you'll see this on every single square root that I write. So for what it's worth, you don't have to do it. But if you like it, take it for your own. And then years from now, when you're a math teacher, you can say, this is what I learned in high school from my math teacher. All right, cool. Where were we? We were thanking Avery, and we were asking Mr. Ahmed, down to y equals?
Root of x. Whole 1 minus 2.
Sweet. Thank you. Oh, not here.
Okay, it's y equals square root of x plus k.
What does k have to be in order to make this go up?
Probably does have to be negative.
Ooh. Positive makes it go up, right?
Yeah.
So what value of k makes it go down?
Negative.
Yeah.
Negative, yeah.
Plus k, where a positive number makes the whole thing go up, a negative number makes the whole thing go down. Remember, plus and negative is the same as minus. So we have to sort of keep that in our heads. Adding a negative and subtracting are the same thing. Cool. We go to that? Did we all try it in our Desmos and slide the slider back and forth and watch the thing go whoop, 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 whoop? Did it make that noise? Remember, if you got an idea, just type it into your grapher, see what it does. See if it makes it do what you think it should do. Ooh, what did that one do? You might want to make a note of that, because what am I going to ask you later? Hey, how do you think about that? Oh, just whizzing ahead. Nice. So, is it making it move in the correct direction? You've got a negative value of 8, and it seems to move right. But I want it to be the opposite. Nice. So that's the opposite of what I wanted. Oh, no, it isn't. Left by 3, right by 4. Okay, no, you're good. In my head, I had those backwards. Look at you. Nice. So type that one in, make a slider.
Mhm.
Tell me if it does what I want it to do. What do you think? So you've got this. You left the square root of x alone, but you added a quarter to make it go up, right? So we definitely want to leave the x in there, so we don't want to get rid of the variable. If we just get rid of the variable, well, now we don't have an equation. Well, we got a line, right? But what could we do? When you think about what we did to the other two, what did we do to x squared and x cubed? Where did we add? So that was up and down. Where did we add to make it go up? Ooh, I like it. There it is. All right, let's see what we got. Left by 3. If you're not there yet, that's okay, because we'll find out now. Travis, how do I make it go left by 3?
Travis isn't here.
Travis isn't here. You're Tyler. I knew that. Did I tell you guys about my being really bad at names? Yes, okay, good. Because I am. I'm really bad at names. And now you're all wearing masks. I'll get there. And then my brain confuses similar names. Starts with a T, has some syllables, Travis, Tyler. My brain mixes those up and it takes me a while. I'll get there. Brett. Left by 3.
Square root of x minus 3 or plus 3.
Square root of x plus 3. Inside the square root symbol instead of outside the square root symbol.
Inside.
Yeah. Oh, I was just emphasizing because you said it that way. Alex, right by 4.
Square root of x minus 4
Inside or outside?
inside.
Restock. Luke.
Y equals square root of x plus h.
You guys agree? So let's think what happens here. If h is positive 3, I move left. But I want h positive 3 to move me to the right. What could I change about that equation?
Instead of plus, it'd be subtract.
That's what I want. Consistency, for one. I want them all to be the same. Notice x squared, x cubed, we did x minus h. And I also want a positive value of h to move me to the right, not to the left. If we say y equals x plus h, that would work. But then I have to put in a positive number moves me to the left and a negative number moves me to the right. And then that's awkward because those are the wrong directions. I want this to be negative and this to be positive. So x minus h works much, much better. Okay. Very quickly, how do you think we stretch or compress? What could we do to our equation to make it go up faster or to make it go up slower? Volunteer, Luke.
Add the a.
Add it?
Add. Yeah.
What are we going to really do with the a? I know you mean add by put an A in the equation.
But you would multiply it by x squared.
Or square root of x, right?
Yeah.
Yeah. That's a stretch factor, just like the other two equations. If we multiply this by 2, this goes up twice as fast. This is 2 times the square root of x. If we multiply this by 1/2, it goes up 1/2 as fast. And we have 1/2 times the square root of x. So I want you to put this in your calculator. Hang on, I gotta erase some of my investigation. Graph looks like this. We got y equals a times the square root of x minus h plus k. I want you to put that in your calculator, and I want you to move those sliders around. When I say calculator, I mean Desmos, because you got to make the sliders. Calculators aren't as useful for this. And I want you to tell me about the point h, comma, k. What do you notice when you move these sliders back and forth, when you move this graph around, when you change things? What do I know about the point h, comma, k? So no, this is good. So just keep typing. You know, have the square root in keyboard. And then it should have a square root, so there it is. And now, there you go. And do you know how to now get out of the square root symbol and do the k? There you go. Now just type 3 plus 3. And then of course the answer would be what the red sliders is. Yes. Cool. Now move h and k around. What do you notice about the point h, comma, k? Yes. Oh, except we want a minus h under there, right? And then arrow to the right. Hit the arrow key once. And now put plus k. And see now, notice it puts it outside the square root. And if you wanted, you could go all the way back and stick an a in front, but you don't need an a for this question. But when you move that around, what do you notice about the point h, comma, k? So what right now is at 1.3, comma 1 on your graph? Guys feeling like you got a handle on this? When you move it around, when you're sliding h and k and your whole graph is moving back and forth and up and down, Luke, what do you notice about that coordinate right there?
The h is the extra value and the k is the y value of the starting point all the time.
There it is, the starting point. If I take this graph, which starts at 0, 0, and I move it left or right by h and then up or down by k, the h becomes the x value, the k becomes the y value of the starting point. So if I give you the equation y equals square root of x minus something plus something, you could say, oh, look, there's the starting point. Let's try that. Let's see what happens. Here we go. Ready? Example. Y equals square root of x minus 2 plus 3. Where does this start? Anybody? Volunteer? Avery.
-2, comma 3,
Negative 2 comma 3?
+2,
Which? 2 comma 3, agreed. X minus h. H equals 2. K equals 3. If I go 1, 2, 1, 2, 3, this starts right here. And now, what's the first point for my quick graph? Isaac, what's the next point of my quick graph? How much do I go? Over 1 up 1. There's another point right here. Annie, where's the next point for my quick graph?
oh no,
We started here. We went over 1 up 1. How much?
4, 2,
Over 4 up 2. 1, 2, 3, 4. I put some more points on there. Up 2. Gonna be right there. Oh, look. There's my graph. You cool with that? Does it make sense? Okay, your turn. Here, practice for you. You're going to draw a quick graph. You're going to draw a quick graph of y equals square root of x plus 1 minus 3. Go. I want a beautiful graph, the best you can do. In your notebook, without using your calculator. It's so easy though. Where's the starting point? Where are the quick graph points? Boom, graph. I should have said that before. Uh-oh. What's the shape? You have your document. Remember, increasing concave down. This would be decreasing concave down. So you're headed in the wrong direction. And then that would be increasing concave up, right? So think about the shape here. That doesn't change. All we've done is take that graph and moved it over and down. So you're still going to start at this starting point and go that way. And where are your 2-point graph points? The table. Those are your quick graph points, right? You're starting here. Where's your first one? Okay. No. This was your starting point, right? But you moved the whole thing over and down. And now you're starting here instead of here. So how much do you go up and over to get from your first point to your second point? Up 1 over 1, put a dot. Next point? Boom. Oh, wait. Not up, that's over, right? Oh. Nice. Oh, where should your starting point have been? Uh-oh. Minus to the right. This is to the right. That's down. So starting point is.
1, -3.
I'm gonna say instead of 1, remember that's the opposite, because that's that x minus h, so it's -1, -3. And then the other thing is, remember, the graph should be increasing concave down, right?
Okay, yeah.
All right, here we go. Let's talk. Alex, starting point.
-1, -3.
We all go to that? Yeah, I am. 1, 2, 3. 1, 2, 3. -1, -3. There's my starting point. Quick graph. Where is my next point? Isaac. 0, -2. How'd you get there? Yeah, over 1, up 1. You could say 0, -2, or you could just say to yourself over 1, up 1. Either way is going to get you there. Over 1, up 1 is less thinking. Boom, you got a point on the graph. Annie.
Still graphing.
Okay, but where's my next quick values? What are my next quick values after what Isaac gave us of over 1, up 1?
4, 2.
Which is over, which is up? Over or up? So therefore that must be? Boom. So here we go. 1, 2, I'll put some things on there. 1, 2, 3, 4. 1, 2. Remember, I'm always starting from 0. 1, 1, 4, 2. And remember that the graph can't change its shape. I saw some people trying to draw graphs like this, or trying to draw graphs like that, or trying to draw graphs like this. The graph doesn't change its shape just because you slide it back and forth. The only time it changes its shape is when you put a stretch factor up front. Could either make it steeper by putting a number greater than 1, or you could make it flatter by putting a number between 0 and 1. And what happens if I make it negative? Anybody? What happens if I make a to be a negative number? All these positive values become negative values. It'll flip over and go down. If I make a less than 0, it'll look like that. Because yesterday we talked about h comma k for the cubic. Anyone remember, or if you got your notes, maybe flip back and look at your notes. What did we call that point? It was right here. We had a special name for that point.
Inflection point.
Thank you, Tyler. I'm practicing saying your name. That's the inflection point. Changes from concave down to concave up. How about the quadratic? The parabola? Anyone want to tell me what h comma k is? Is that a yes? Your eyes looked super enthusiastic for a second there. Brett?
Vertex.
For the parabola, it's the vertex. Defined as the lowest or highest point on a graph. Quadratic, which of course is why a cubic doesn't have a vertex, because it doesn't have a highest or lowest point. And this doesn't have a vertex, really, because a vertex is usually considered you come down and then you stop and you go back up again. You keep going. An ending or starting point isn't generally considered a vertex. Questions? Ready for another one? New function? All right. Let's clear off this area here. I'm going to have to make room. Never mind. Okay, here we go. Cleaning the board. Here we go. So I'm going to be asking you the exact same questions. New function, y equals the absolute value of x. Now, before we get into the investigation, let's remind ourselves what absolute value means. Absolute value function tells you the distance from 0. This is why absolute values are always positive, because it's a distance from 0 and we don't care which direction. There's a really, really obvious example of absolute values. How many people have ever ridden in a car? Just think, if I'd asked that 100 years ago, people would be like, really? You've ridden in a car? That's so cool. Of course, we've all ridden in cars. Does the speedometer tell you which direction you're going?
Yeah.
Doesn't. It just tells you how fast you're going.
Well, it points
If I
straight.
drive down Laurel at 40 miles an hour, my speedometer says 40, agreed?
Yeah.
What if I turn around and go that way? Does it say negative 40?
No,
No, it just says 40.
but it points to the way you're going.
It doesn't actually. Because it's a dial, right? I mean, it points at whatever number it's pointed at. Guys, that's an absolute value because you don't want your speedometer to say negative 40 when you're going the other direction, because that would be weird. And then what would it say when you're going at an angle? You get on one of those roads, it doesn't go east, west, or north, south. Well, if I'm driving that way, is that negative or positive? Well, I don't know. I just want to know how fast I'm going. So absolute value can be very useful if you just want to know a value and you don't care whether it's positive or negative. And speedometer is a really good example of something that tells you an absolute value. Okay? So how do I find the absolute value function? In your graphing calculator, it is under the math menu, and then it's under the number function, and the very first one says ABS parentheses. In Desmos, if you look at your keyboard off to the right, and I don't have an example of a keyboard, but notice where I better look just, here. Let me look at mine and make sure I'm telling you the right place, because that would be awkward. Find the Enter key. Everybody look on your keyboard and find the Enter key. Look right above it. The key right above it has a backslash and a bar. You can just type that bar and then put X. You can also, in Desmos, I believe, just type the word ABS and it will automatically make that. So play around a little bit. I want you to get y equals absolute value of x in Desmos. And then I want a full investigation. Table, graph, intercepts, domain range, all that good stuff. I know. We've done this investigation, so many things. We're probably dreaming about it, huh? Wake up, oh wow, I investigated like 3 really cool functions last night. Oh well, no, that was a dream. What a great dream.
That'd be a nightmare.
Wakes up, can't remember what they did the night before. Oh, man.
All right, investigating, let's go. See X, Y intercepts, domain and range, important points. Asymptotes. Description. Remember your table, just be thinking about quick graph points. What's the minimum I need to make this a beautiful graph? Morning, Travis. Travis, we are investigating the absolute value function. And if you go into Desmos, you can either use that key right there, which has a vertical bar on it, or I think you can type ABS and it will make you an absolute value function. And just a reminder, absolute value function is one that just tells you the distance from 0. So it makes the numbers positive. I don't see anything.
Lost.
Well, have you typed in the equation into your grapher? So let's get rid of those.
These are part of this equation. That's what we're doing.
Yeah, but that's square root. That was the last one. We're on the new one. So we need to start over again. I'd erase all that stuff.
Everything else goes with it.
Yeah. So now we're gonna do new equation, y equals absolute value of x. Oh, look, there's even an absolute value symbol there. Ha! Look at that. It gets easier and easier. Don't forget your equals. And then put an x inside there. Boom. Do a full investigation. So, why does yours have completely different symbols than his does? Oh, that's interesting. Yours is completely different. There's the absolute value. But what you'll want to do is actually go back and put y equals and then the absolute value. Huh. Interesting. All right, full investigation. All the things on the board. See the little list I made? X and Y intercepts, domain and range, important points, asymptotes, description. No, but I completely agree with your domain. Yeah. Oh, really stuff at 0, does it? If you were completely done with your investigation, you're like, oh my gosh, that was the easiest thing I've ever done in my life. You can start thinking about how to make it go up or down, how to make it go left or right, how to stretch it or compress it. I'm just coming around to check your investigations. So instead of saying 0, is there an asymptote? When you say zero, did you mean there's an asymptote at zero, or did you mean there are zero asymptotes?
There, zero.
I would say none instead of zero, because zero sounds like a number, and then people start to think, well, wait, okay, there's an asymptote. That make sense? Yeah. Exactly, there is no concavity, so it is instead what? Yeah, but if there's no curve, what do we call it? What's the word for a thing that doesn't have a curve? There it is, it's a line. Yeah, so depending on this, it's gonna be two separate areas, right? Over here, it's doing one thing, and over here, it's doing another thing. We sort of saw that though with x cubed and x squared, didn't we? Like x cubed, it was increasing but concave down, and then it was increasing but concave up. So it's okay to have two separate little descriptions saying on one side it does this and on one side it does that. Cool. How about the domain? How far does it go to the left?
Like infinity. It's just infinity.
So this isn't really infinity positive direction. What's the difference?
Maybe.
It really start at zero and go to the right.
Yeah, it starts at zero.
Yeah, it starts at zero and goes, but what does it do in the left right direction? So my domain is gonna be a little bit different.
Yeah.
What's the domain gonna be?
Would it be out here?
How far does it go that direction?
4.
Really?
Like,
What if I made my graph? There you go. Only goes to 4 because that's where you chose
Yeah.
to stop your
Yeah.
graph, right? Be careful with description. I agree with you on line, but that doesn't look like a line really. All right. We're gonna take a little pause and then we're gonna continue to talk about investigating functions because I know they're gonna ask us to.
Good morning, Meridian.
Rise for the Pledge of Allegiance.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you. You may be seated.
Any students that would like to attend the football game on Saturday need to sign up in the athletic office. Space is limited. Seniors will be given priority. The last day to sign up is tomorrow. Students will be notified on Thursday if they're able to attend the game. Any students wanting to attend the volleyball game tomorrow need to sign up in the athletic office as well. Your name needs to be on the list to be able to attend the volleyball game. Did you know that breakfast and lunch are being offered at school right now is free for anyone? So help yourself to a breakfast snack or grab lunch on your way home.
And in sports, today girls soccer at Wacom Community College at 3 p.m. and you do not need to sign up to attend. Tomorrow, cross country is at home versus Blaine at 3 p.m. and you also do not need to sign up to attend. Volleyball at home versus Linden tomorrow as well, but students do need to sign up to attend. Thank you, Meridian. Have a good day.
How do you watch cross country? Just like run along next to them?
I guess. Seems like they're
What's the finish line from?
Once the finish line would make sense, so you don't even have to say, okay, how long is it gonna take? Oh, wait. How long is it gonna take you to run 5 miles? Okay, I'll see you at the finish line there. Okay, I don't have to be there when it starts, I just have to.
There's a reason why you have to sign up for football, but not cross country. Because nobody's gonna watch you run cross country.
Well, and plus you're gonna sit in the stands. Okay, we have orange juice. We have, wait for it, Simply Wholesome oatmeal bars. Strawberry flavored. They have actual strawberries in them. Hang on a second. Ingredients, here we go, ready? I'm looking. There's apple in them. Interesting. There's raisin paste. Okay, raisins, so ground up. Strawberry bits. Strawberry bits are made from, are you ready for it? Sugar, soybean oil, this is in order. Whole grain wheat flour, strawberry powder. These are the ingredients of strawberry bits.
Yeah, but what is strawberry powder? It's just like saying how to make cookies,
Well,
but then using a completely different ingredient.
I'm gonna cross my fingers that strawberry powder means we dried strawberries and then we ground them up and made them into a powder, as opposed to artificial strawberry flavored powder that doesn't actually come any within 1,000 miles of an actual strawberry.
Then why not just do powdered strawberries?
I don't know. Anyway, these may actually be good. They're here. Grab yourself if you want one. I'm gonna turn my phone off because it keeps doing that. Grab a snack if you want one. Now's your chance because she's gonna come and take them. And if you didn't grab one, you're not gonna have had an opportunity. And then when your stomach's grumbling later, you can't say, "Oh man, I wish I had a snack." Okay, so we got a few people who are gonna be brave and try the strawberry powder. Excellent, I'm excited to hear.
I have to read the ingredients. I'm so skeptical.
Yeah, but it's got like whole wheat and all that good stuff in it. Okay, I wanna hear. Taste, tell me how it is.
I'm starting to doubt that there's even any strawberries in there.
It's good. He says it's good. Anyone else? Avery? Good? It's okay?
How's that? That's good.
Cool. Matt will probably give you orange juice as well. So you can have strawberry powder flavored orange juice. All right. Guys, let's continue the discussion about y equals the absolute value of x. So here we go. Avery, pick one thing. Tell us about it.
I'll do the table. Just 1, 1. Sorry, 2, 2. And then go up and you put 0, 0. -1, -1. And then -1, 2. At the top. I mean -2, 2.
Sweet. I'm going to make the graph. Here we go. 1, 2, 1, 2, 1, 2. Boom, 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 boom. It's pretty easy, quick graph. I like the fact that Avery went to 2 and -2, because had she only gone to 1 and 1, sure looks like a parabola, doesn't it? So going the extra step to recognize that this is not a parabola is I like it. I like it. Now, if you were just asked graph this function, you don't really need the other ones because you know what it looks like, so you can do the first 2 and then draw your lines. But you don't want somebody else to be fooled. All right, thank you, Avery. Tyler, pick one.
X, Y intercept,
Or where?
0, 0.
Tyler, are there any important points on this graph?
Yeah,
Where?
0, 0.
What do we call that point, Tyler?
The origin.
Ooh, it's the origin on the graph. What is it on the absolute value function? What? You agree?
Yeah.
Yeah, it is the lowest point on the graph. This is, in fact, a vertex. So this is another function that has a vertex because it comes down Instead of being a nice smooth curve, it comes to a point. But it is in fact a vertex. Excellent. Thank you, Tyler, and thank you, Alex. Brett, pick one. Go, domain.
Negative infinity less than x less than infinity.
Range.
0 less than equal to y less than infinity.
Cool. Notice this one goes forever in both directions, left and right, but up and down it starts at 0 and goes up from there. Cool. Thank you, Brett. Eddie, pick one.
Asymptotes. No.
Good. Guys, if there are no asymptotes, don't say 0. Because the problem with saying 0 is that then your reader starts to think, wait, is there an asymptote somehow associated with the number 0? But if you just say none, yeah, this goes up forever in both directions. And Travis, asymptote, a line that a function approaches but never reaches. All right. Last name? Wait, Brett, you're in here twice. I bet that's from my other class. Did you feel like you were getting called on a lot? I do have a Brett in one of my other classes. Luke, pick one.
Description.
Okay, good. How would you describe this function?
Well, I'm not sure about the angle. It's just like a line.
Okay, so it is linear, a line. The word linear means the shape of a line. Tell us about that linear, because that doesn't look like a line to me. Lines, to me, look like that. And they go on forever in both directions, just like that. What's the difference? I agree with you, it's linear, but what's the difference?
That's a 90-degree angle.
Do we know that it's 90-degree angle?
Exactly.
And here's the problem. Will it always be a 90-degree angle when I stretch or compress it? Tell me about increasing and decreasing.
It's decreasing and then increasing.
Good. It's decreasing on the left, and then it's increasing on the right. Coming down, and then it stops coming down, and it starts going up. Guys, if you use the words increasing and decreasing, and concave up, concave down, you'll almost always get a great description. In this case, there is no concavity because it's linear. So we switch the word linear for concave. Cool. Nice investigation. Anybody remember when you first investigated a function in this class months ago and you're thinking, oh my gosh, this whole investigation thing's so confusing. And now you're banging them out. It's like, oh look, investigation. Oh look, investigation. All right. How do you think I'm going to make this function go up or down? We've restocked. I want to make this function go up or down. Travis, you got any ideas on making that go up or down? I know you weren't here for a lot of the.
Probably like adding a number at the end.
Yeah. Boom. There we go. If I want to go up or down, I'm going to add a number to the end. Y equals the absolute value of x plus k. And if k is positive, I'm adding, which means the whole thing slides up. And if k is negative, that's like subtracting, which means that the whole thing goes down. Cool. Hey, Travis. Eddie, how about left or right? Y makes it go up or down. What letter should we use for left or right?
X,
X is our variable.
Y.
Y is a variable.
I'm out of letters.
Wait, you've only used 3 of them. There should be 23 left. And that's assuming that we only use our alphabet. We don't switch to Greek or Hebrew. Annie,
Oh,
what do you think? Save him. Where would I put a number that would make this function go left or right?
On the outside of the absolute value.
Well, but the outside made it go up or down. So what's the other possibility?
X plus 4.
Let's try that. Everybody put that in your grapher, into Desmos, and see what it does.
Holy feelings. That's a cheat.
Annie, which direction did it go? Good. This went left by 4. So how am I going to make it go right by 4?
Subtract it.
Subtract absolute x minus 4 will make it go right by 4. How about by h? And I want h greater than 0 to be right. And I want h less than 0 to be to the left. Let's see. I have to think about this one. Volunteer? Anybody got any ideas what I could do with the h? Nobody wants to volunteer on this one? Isaac? Guys, are you starting to see a pattern?
Yeah.
Look at what we've done so far. Cubic plus k. Quadratic plus k. Square root plus k. Absolute value plus k. Always makes the function go up or down. K positive, k negative. X minus h cubed. X minus h squared. Square root of x minus h. Absolute x minus h. Always makes it go left or right. H positive, h negative. How about stretch? What if I want this v to be steeper? What am I going to do? What do you think? Luke?
Put an A to the left of the absolute value.
And what is the a going to be to make it steeper?
Greater than 1.
Greater than 1. What if I want to make it flatter? Anyone?
Between 1 and 0.
Between 1 and 0. Multiply by half, everything gets half as big, right? What if I want my v to go downwards?
Negative.
Negative, because all my positive numbers get flipped over and become negative. Now, this sometimes confuses people because they say, but Mr. Armitage, absolute values are always positive. But if I put a negative out front, y equals the negative of absolute x, notice that it makes it positive first, and then it puts a minus sign out front. So that becomes a negative number. There's our graph. Here's our general equation. I want you to type that into Desmos, and I want you to figure out what we know about H comma K. What do we know about H comma K? So drag your sliders around. Look at that point H comma K. Where is it on the graph? No matter where you drag your sliders, where is H comma K? Avery, you see anything?
When you move H, it moves left and right.
Good. The whole thing moves left or right, agreed? And then
K is up and down.
the whole thing moves up and down. So what do you find on this graph at that point right there if you move it left, right, and up, down?
Just like the point of origin.
Well, the origin, again, the origin is the point 0, 0 on a graph. But you've just moved it, right? You've moved the graph away from the origin.
What's the vertex?
The vertex is going to be there. Because that vertex will move H to the left or right, and then it will move K up or down. And right there at H comma K, you're going to find the vertex. That makes sense? You guys cool with that? Guys, here's the point of this lesson. Here's the point of everything that we have been doing so far in Algebra 2, is to get comfortable with manipulating these equations. If I give you a graph, you should be able to identify, oh look, it's an x squared function. I give you what doesn't have a name, a cubic graph, the S-shaped one. You say, oh look, it's cubic. I give you one that starts here and goes like that. And you say, oh look, it's a square root. I give you one that looks like a V. Oh look, it's an absolute value function. It's not the charging system. It is probably, now that I think about it, in the wiring between the charging system and the computer. And it cost him $600 to buy a new charging system because I got sloppy. I didn't think about patterns. He was telling me it was charging funny. And to be fair, he didn't do a very good job of explaining to me what it was doing when it was charging. Because after I got the charging system done, I looked at what it did when I fired up the bike. And I thought, oh dear, that's not a charging system problem. I cost my customer $600 because I got lazy and I got sloppy. And I didn't think about the pattern. I heard the words charging system. I said, this is probably what it is. Now, had it been July and he'd come to me with the same problem, I would have said, I'll come over and I'll check everything out. I would have checked everything out and we would have discovered that the charging system was fine. And then there was a problem in the wiring and I would have fixed the problem in the wiring and he would have gone about his business. Probably 2 or 3 hours of labor, $100, $150. And instead he had to buy a charging system because of a combination of things. The point of the story is that you always have to be thinking about these patterns. I got sloppy, I got lazy, I cost one of my customers $600. Now, have I told him I cost him $600? Well, not yet. I said, well, looks like we still got a problem and I'm gonna go back, and I will admit it, I probably won't charge him to go back and fix, you know, what's actually wrong, which is gonna be an easy fix. I will just go back and I will fix it. But what's the point of my story? The point of my story is that when you are working at a job where you're responsible for all this, for anything, at any level, whether somebody says, here, you're gonna be in charge of this, or whether you have your own business and you're in charge of everything, you gotta constantly be thinking about those patterns. And after 25 years of being a Harley mechanic, it's really easy to sometimes get a little bit sloppy and cost a customer a bunch of money. In fact, I went on to B-Twin Forums, which is a motorcycle forum I go on a lot to ask questions, and then I'll answer questions too when I see things that people have. And I posted up what had happened, and the very first guy that came back was a guy who I've been reading his stuff for 15 years on the forum, and he's good. He knows what he's doing. And the first thing he said is, well, did you test the charging system before you replaced it? And I went right back, and I had to just admit it. I said, no, I got sloppy and I should have, and I screwed up. I said, I typed that right into the forum. I said, I screwed up. And so now I'm trying to track down exactly, and he made a couple suggestions, he came back and made a couple suggestions. He said, well, check this and check that. But, you know, it wasn't easy to just, I completely screwed up in front of all. I mean, I've been posting that thing, like I say, for 15 years, and I got a pretty good reputation, and to be able to have to go in there and say, wasn't easy, but there you go. Okay, so what does the rest of this week look like? Guys, you have no assignments Wednesday and Thursday. On Thursday, I will be posting a Chapter 2 quiz. 4 questions. They are mostly related to quadratics, because that's what we spent most of our time doing. We'll be quizzing on this other stuff after we come back from spring break and after we've had a time to look at it a little bit more. So there's going to be stuff on quadratics. I put up a little review worksheet. It is optional, but if you do it, I will give you points. I recommend you do it. It's basically extra credit. Okay, it's going to be out of 0, but I will give you points if you do it, so it can boost your grade a little bit. And it will be a good review for the quiz, because the questions on the review worksheet directly reflect the questions that are going to be on the quiz. The quiz will be due by Sunday night. It will close Sunday at midnight, so make sure you get it done over the weekend. Don't forget, it will pop up on your Google Classroom calendar. You all look at that on a regular basis, right, to see what you have due? Yes? Okay. Guys, if you don't do the quiz, you just dig yourself a deeper hole if you're already sitting at an incomplete because you're not turning stuff in. You're just going to dig yourself a deeper hole. Get these assignments done. And over the next 5 weeks, might not be a terrible idea to go back and get some old assignments done so that when you come back after spring break, you're not already starting with an incomplete. I know you're going to have 3 other classes to think about, but get those corrections done, turn in assignments that you haven't gotten done, get that incomplete up before we start again. Life will be easier. Okay? Awesome. Hello. What? Oh, don't forget the orange juice.
In 5 weeks, I think.
Oh, in 5, okay.
In 5 weeks.
No, it's fine.
Yes, we have a 5-week spring break because with nowhere to go. Hey, if you got trash, there's a garbage can by my desk. There isn't one up here, because they only let me have one garbage can. Ah.
It's not wet now.
Look, it's Tuesday already.
Yeah.
Why do you have a giant ramen noodle soup sweatshirt, just out of curiosity? Was it like you collect enough ramen noodle soup packages, they send you a free sweatshirt?
Oh, God.
Oh, you know.
Because, and the only reason I have, nothing wrong with it, it's perfectly good sweatshirt, but I can't, I'd be walking through a store and I think to myself, oh, no, I don't really want a ramen noodle soup sweatshirt. It's cool though, I love how it's got like all the pictures of all the ingredients, you know, that's funny.
It's dry, just one.
If I'm. And it bounces, somebody.
Did you hear it?
Yeah, I watched it.
Every-
And I spent $700 on tires.
Oh, Wednesday, wait.
Yeah, when it's wet, I feel.
All right, guys, have a great day,
You too.
have a great week.
Thank you.
You betcha.
Like a light and a comment on
Thank you.
You're welcome.